Okay, this is over common logarithms. Please be following along. All right, now here's the basis of this: is common logarithms are always we're dealing with base 10. So if we have 10 to the power of something, so b right now is my exponent. I'm making this very general. Equals a number, okay? A and B are just two numbers. Doesn't matter what they are. Now I'm going to make the connection with the logarithms. Then the log of this number is my exponent. Okay, there's a couple ways of thinking about this, of easily remembering this. These are cues that your other teachers in this school will say. The answer to a logarithm is an exponent. So if they cue you by saying the answer to the logarithm is, you should say what? An exponent. The answer to a logarithm is an exponent. The answer to a logarithm is an exponent. All right? It's the same way of saying the log of a number. So let's say I have the log of a number. The calculator is asking itself, 10 to what power is this number? Ten to what power is this number? So the first thing that we were focusing on was the computational aspect of logarithms, meaning the number relations. If you put this in your calculator, what does that answer mean? Well, it's telling you 10 to whatever power it gives you is that number that you punched in your calculator. Okay? Log of a number gives you the result of an exponent. 10 to what number is that? 10 to what exponent is that number? So, let's say I have 10 to the x power equals 14. I want to know what that exponent is. So, I take the log of 14. Log of 14. That's all you have to put in your calculator. Log of 14 equals 1.1461. All right, so let's say I had to phrase this differently. Well, that means 10 to the 1.461 equals 14. Again, focusing on the computational aspect. Where we're going today, solving exponential functions. Now we're going to see how we use logarithms to help us solve algebraically. Okay? So if you think of it this way, it's ways to undo certain parts of an equation. If you see addition, how do you undo addition? Subtraction. If you see multiplication, how do you undo multiplication? Division, and so on. So right now, as a reminder, that's order of operations, right? If you're computing something, you go in this direction. But to solve, we have to go in the opposite direction. That's how we solve. To solve.
What does that mean? Like, isn't it? Well, yeah, but aren't you solving?
Parentheses, exponents, multiplication and division, addition and subtraction.
Like, why are you going backwards? Because you're like, what are we solving? If you're solving, then you.
That's what we're going to be focusing on. So, okay, let's say you have this. 3x minus 4 equals 8. How do you know what to do first?
Add 4.
You add 4. Okay, so you go backwards to solve. You knew you'd have to use addition or subtraction first. So now 3x equals 12. Well, what's left? Division. Divide by 3, and x equals 4. That's how you have to process that. You are going backwards. You may have never realized it, but that's actually how that works. What's that? When you solve.
What does that do with logarithms?
That's where we're connecting this to. That's what the focus is for today. Okay, so again, the opposite of subtraction is addition. The opposite of addition is subtraction. Opposite of division, multiplication. Opposite of multiplication is division. Now, here's what we're focusing on. What do we use with exponents?